All right, so today we're going to do lesson 9.2, simplifying radicals. Remember, a radical is just the square root sign, okay? What I need to do is I need to simplify these numbers underneath the radical because I look at all of them and I notice that none of them have an exact square root. The square root of 50. There is no number that multiplies with itself to give you 50, okay? 25 would not be it because 25 times 25 is 225, okay? So I need to figure out how to simplify these square roots because I don't want to change it to a decimal. And the easiest way for me to tell you to do this is to use upside down division. What you do whenever you have upside down division is you take the number that's underneath the radical. Right now, underneath the radical, we have 50. So I'm going to write 50 here, and I'm going to do the upside down division bar. Okay? 50 in an upside down division bar. And what I'm going to ask myself is what is the smallest prime number that can go into 50? Now, a prime number is any number like 2, 3, 5, 7, numbers that only multiply with 1 in themselves to get that number. So 2, 1 times 2 equals 2. There's no other factors of 2. 1 times 3 equals 3. There's no other factors of 3. Okay, so that's what a prime number is. And I always want to ask myself, what is the smallest prime number? Because that way it helps keep them nice and organized. So what is the smallest prime number that can go into 50? The smallest prime number that can go into 50?
5.
2. Okay, I want the smallest. All right, so I have a 2 here. And then I say, okay, 50 divided by 2 leaves me with 25. So I write 25 right here. Now, I say, okay, 25, I can reduce that still. What's the smallest prime number that can go into 25? 5. 25 divided by 5 is 5. Okay, now, this is the part. I've got all prime numbers, 2, 5, and 5. There's nothing I can do to simplify these numbers anymore. So, I look for pairs. Pair is the same number written twice, okay? I look for pairs. I have a pair of 5s right here. What I want to do is each pair is going to signify one whole number that I can take out from underneath the radical. So when I have a pair of 5, it just represents one number. And that one number that I'm going to take out is 5. Now, what's the only thing I'm left with? 2. I have a 2 left on the outside. So that goes back underneath the radical because it is all alone and it does not have a pair. So my final answer would be 5 times the square root of 2. Just remember, when you have a pair, it only represents one number, not 2. Don't pull out 5 times 5 is 25 or 5 times 2 is 10. Okay, you just pull out one number. All right, so let's do the next one. Square root of 48. I asked myself, does 48 have an exact square root? No. Is 48 a prime number? No. So I can simplify it. Okay, let's do upside down division for 48. I've got 48. Do my upside down division bar. The smallest number that can go into it, prime number. So the smallest prime number that will go into 48 is 2. So I write the 2 on the outside, and I have 48 divided by 2 is 24. Smallest prime number is 2. 24 divided by 2 is 12. 2 again, and I'm left with 6. 2 again, and I get 3. All right, let's look for pairs. I've got a pair of 2s. I've got another pair of 2s, and then I've got a 3 all left alone because it does not have a pair, okay? Whenever you have 2 pairs, each pair represents how many numbers? 1, okay? So I've got a 2 that I can take out, and I've got another 2 that I can take out. What I do is you always want to multiply. If you have multiple numbers that you can take outside of the radical, you multiply them together. So 2 times 2 equals 4. So I write my 4 on the outside, and what goes back underneath the radical? The 3. All right? Now I've got square root of 2 times the square root of 8. instead of sitting here and going, okay, I'm going to need to do upside down division on these, which I really can't do upside down division to 2 because 2 is a prime number. So what I would suggest that you do is anytime you have two radicals being multiplied, I would multiply the numbers together and keep the radical sign. What's 8 times 2? 16. Well, that's easy. What's the square root of 16? That's my final answer. Just go ahead and multiply them together. Now, if that was like 2 times the square root of 8, I could not do that. What makes that possible is they both have the square root signs. All right, so let's move on to some fractions. Simplifying a fraction underneath a radical. I've got the square root of 7 over 16, okay? And the easiest way for me to tell you to look at this is look and see if you can simplify what's underneath the radical. Can I simplify 7 over 16? No. So then I'm going to say, okay, I can look at this, and since that square root sign is over both numbers, it technically means the square root of 7 over the square root of 16. Okay, that makes it a little easier to look at. Can I simplify the square root of 7? No, I cannot. Okay, it's a prime number, so guess what? It stays the square root of 7. Can I simplify the square root of 16? Yes, what is it? 4. Is there anything else I can do here? Nope. This is my final answer. All right, let's do this next problem. Can I simplify 1/4 underneath the radical? No, okay? So I'm going to go ahead and write it square root of 1 over the square root of 4. Guess what? These are both perfect squares, which means they have exact square roots. What's the square root of 1? 1. What's the square root of 4? 2. Okay? Final answer. The fraction underneath the radical, 10 over 2. Can I simplify it? Yes, to what? 5. So this is going to become the square root of 5. Can I do anything to simplify the square root of 5? Nope. Final answer. And lastly, the square root of 18 over the square root of 3. Now, I'm sorry, the square root of 18 over 3. I do not have a square root sign over 3. So that 3 is going to stay just like it is. But I can reduce 18, or I can simplify 18. So I'm going to do upside down division. Okay.
Open the door.
All right, so I'm going to do upside down division with 18. So what's the smallest prime number that can go into 18? 2. That makes this a 9. What's the smallest prime number that can go into 9? 3. I'm left with a 3. So what do I have that's a pair that I can take out? The 3's. Okay? So I'm going to take the 3 on the outside times the square root of, what am I left with? 2. And I'm going to put that over 3. Now, once you pull the 3 on the outside, that is a whole number now, okay? It's fair game. What I can do is if I give you the fraction 3 over 3, all right, what would you simplify that to? 3 over 3. 1. Very good. That's exactly what you have here, 3 over 3. Just because it's on the outside of the radical does not mean you cannot simplify it. Technically, I can pretty much cancel that out because I could just write this as the square root of 2. Now, I could also write it as 1 times the square root of 2. Either one of these would be the correct answer. All right, so let's do the last example here. All right, I've got 2 times the square root of 3 over 4. Now, I've got 2 as a whole number on the outside, okay? And since I'm dealing with a fraction underneath the radical, I like to go ahead and make that whole number a fraction. So I'm going to write 2 over 1 times the square root of 3. I'm going to break it down into 2 square roots over the square root of 4. Can I simplify the square root of 3 at all? No, I cannot. So what I do is I have to multiply. Now, I cannot multiply 2 times 3 and get the square root of 6 because 2 does not have a square root sign. So what I do is I put that 2 on the outside times the square root of 3. That's how it's read and that's how it's written. Okay? What's the square root of 4? 2. So 1 times 2 is 2. What can I do with 2 over 2 here? Cancel it out. All right, and I get the square root of 3. That would be my final answer. All right. Let's do negative 2 times the square root of 27 times the square root of 3. Okay? Let's do upside down division of 27. 27. The smallest prime number that goes into that is 3. That becomes a 9, a 3, and a 3. Okay? I circle my pair of 3s and I put it to the outside. But look at the outside. There's already a negative 2. So what do you think I'm going to do with that negative 2 and 3? Multiply them. You always want to use multiplication. So this is going to become negative 6 times the square root of 3 times the square root of 3. Negative 6 times the square root of 3 times the square root of 3. Now, since I have the two radicals, what can I do with the numbers underneath them? Multiply them. So I'm going to have negative 6 times the square root of 9. What's the square root of 9? 3. Negative 6 times 3 equals what?
Negative 9. No.
Negative 18. Okay, multiplication. All right. Now, the last problem that I have here is I've got the square root of 10 times the square root of 16 over the square root of 5. Let's go ahead and simplify any exact squares that I have. All right? I've got square root of 16, which is 4. And what I like to do is I'm going to write that 4 on the outside. I cannot simplify the square root of 10, and I have the square root of 5. Now, just like I said before, whenever you have the same square root symbols and they're being multiplied, you can multiply the numbers underneath them. Whenever you have the same square root symbols and they're being divided, guess what? You can divide the numbers underneath them. So what's 10 divided by 5? 2. So this is going to become 4 times the square root of 2. And that would be my final answer. All right?